let me take one moment to reflect backward for 1 second before talking about the road to the future, as John said. Where did we come from technologically? When we started the company, we said, this is going to be a long journey, becoming a database. Let's start with essentially a simpler problem. Let's build the world's best cache. We'll build a system that is available, that is capable of millions of transactions per second. I thought to myself, what happens with, at the time, the Yahoo front page, which was the biggest property in the world? The Yahoo front page was a Rube Goldberg of a system that required 15 full-time engineers, a bunch of Berkeley DB servers, a whole bunch of files that were copied back and forth. And I realized, as Srini said, that it would be difficult for any company to just step in and provide that. How could we help? Were we the kind of engineers who could put together a solution that would allow almost any company to exist at those levels of scale? Well, a persistent cache, one with high availability, with failover, with deterministic routing, a great distributed hash table, essentially, came to mind, but predicated on the advantages of Flash. When we built that, Srini and I have a wonderful little story. I won't go into it at length, otherwise we'll be here all day, and I really want you to hear from other Aerospike users. We said, who's going to use this? I thought it was going to be social media. I thought social media updates, highly read-write sensitive. We went to our friends in social media and they said, you know what? It's 99.9% read biased. Nobody cares if their post shows up this minute or the next minute as long as it shows up. And we were like, oh, gee, our market analysis was completely flawed. I guess we have to figure out someone else who cares. And what we found was the folks in advertising technology. They were gathering and continue to gather, many of you here are in this industry, all of these small pieces of data around the industry that are used in moment-by-moment advertising optimization to make sure that the ads you see on the screen are at least somewhat relevant to you. And that was the first part of the use of this. When we considered our next step, I wanted to do one thing with the company, and we predicated our, let's see, second round of funding on this. I wanted to build more community, and that involved open source. Open source is a complicated topic. Anyone who wants to pull me aside later about the open source journey, I have a few thoughts on the matter. But it is certainly true that in an engineering to engineering relationship, if you can see the code, if you know you can compile it, you know you have a safety blanket, and Aerospike is about building with you the trust together of a great database. So we had to open source the product, which we did. What we also realized was to our journey to becoming a database, we needed more indexes. We needed more complex data structures. We needed lists and maps. Those are incredibly great short-term time series. We needed the ability to run compute in the database with user-defined functions. We needed to start on the journey with enterprise-level security, transport encryption, encryption at rest, etc. And I mention these things partially because some of those of you who might have been in the Aerospike 2.0, Aerospike is a key value store, may be missing some of these features. Right? There may be things that we have spent years and years and years adding to the product that you could be using today that you're not fully aware of. So when you hear other people's use of Aerospike, maybe you should, this is your opportunity to think about what else this cool database we built did for you, could do for you. These feature sets were used for a variety of things. One of them is there's a number of essentially internet applications. Srini mentioned the large-scale telco in India, which uses Aerospike, and it's predicated on these Aerospike 3.0 data feature sets. Creates an application with intimacy I've never seen in any of the US carrier applications. It allows you to see, what's my closest cell phone tower? How full is it? What's the reason for that dropped call? It allows people on that network to feel like they're part of a community. It's a pretty amazing application, and they needed Aerospike to power it, and we're very, very proud of our role in that journey. The final thing that we had to do was support full consistency as a database. And we see this at Aerospike as really stepping into the realm of, I wouldn't say our final step, but a critical step to truly becoming a database and not simply a cache and not an easy-to-use application service. With this promise, which we showed through the Jepsen report, I'm sure many of you have read it, we won't lose your data. And that's a big deal. This is what a database should do. It's what we set out to do day one, is have a database that is not only millions of transactions per second, but high quality, high fidelity, ain't gonna lose your data events. Our track in this was we believed that folks in financial services who are on this systems of engagement journey would need this. However, I've been super surprised at the number of people outside of those industries who really want this. Our friends in social media, finally, if you look around, you'll find some of them here today. They say, hey, look, if I friend Raj, and then I come back to the app an hour later and he's not my friend anymore, that's a destruction of my brand. Some parts of my data must be high fidelity. Otherwise, no one's going to use my app. They're going to switch to some other app. Within the advertising and fraud business, we find that some portions of the data, according to the model and your data scientists, need that data to be correct. Some data is more lossy, some is not. So the amount of work we've put into this has been extraordinary, and in my session this afternoon, we'll go through how we did it, because we invented and applied a number of techniques in sequence to create what we think is a pretty extraordinary database. So that's where we are today. What's the road ahead? The first thing that we think about is how to maintain and continue to increase performance. So I'm going to talk about a few key elements, but I'm going to go back to the fact that we will continue, release by release, to improve performance. There's improvement, performance out there to be had. And our lead engineer, Andy, I recommend meet the engineers at lunch. Where is Andy? I haven't seen him today. There he is. He's never worn a suit coat in his life, which is why I can't recognize him. I bought him some shoes yesterday evening, too. So. Anyway, so we keep finding, his team keeps finding 2x, 3x, 4x speed improvements. If you've been in the database industry, you know that a 2x performance improvement is shocking. You say, as the relational wars came to pass, if you could get a 20% or a 10% here or there, you considered that an excellent year as a database technologist. To get another 2x is extraordinary. Storage efficiency. We're going to roll this out in a few months. We believe in many use cases this will have 2x improvement in efficiency on storage, which means faster reads, faster writes, and, sorry flash vendors, less money spent on flash storage. So 2x on that. That's pretty extraordinary. Not in all cases, it's overhead. Index on device. Very interesting feature. It allows us to cover the use cases that are not sub-millisecond and apply the clustering and high availability that we bring to bear in technology to cases of much, much larger data sets, up through the petabytes and tens of petabytes, where maybe a 5 millisecond and 10 millisecond response time is necessary. So incredibly excited about that. Cluster size increases. We often, Aerospike users feel bad sometimes because they say, my Cassandra friends have 1,000-node clusters. I don't have a 1,000-node Aerospike cluster. That's obviously silly because you'd rather have 10 nodes and pay for 10 nodes than 100 nodes. But still, it is our job to increase scale. We know that all of your businesses are scaling. Data is a tsunami. Therefore, we need to improve that. We have a number of different improvements to do so. So let me show you this graph. This graph came up just 2 weeks ago, a week and a half ago. It is the result of some core engineering in our cluster-to-cluster communication system. We removed a buffer copy. Some of our first users who looked through the code said, Aerospike is incredible in buffer copy use. Well, one of our engineers woke up one day, got super excited about a particular optimization. He's not here, he just got married, right? He's in Hawaii getting married, he gets a pass. Anyway, he got excited and spent 2 months removing a buffer copy, which not only reduces memory use, it increases speed. So this is what happens in red in Aerospike 4.1 when you take a node out of a cluster. The higher number is Aerospike 4.0, and that is the number of transactions above 1 millisecond in latency before and after 2 parallel releases. So I don't know how you want to count that. Peak to peak, it's probably actually about a 4x change in the impact of losing a node. Great change. And that was entirely the excellent engineers we have just saying, hey, I hate this lousy piece of code that is less efficient than it could be. I'm going to propose to our product group, which is to say me and Bharath, a change, because we believe it can make a big difference. That's the kind of engineering we do, and what we commit to you is continual improvement, month after month, release after month, in speed, scale, and reliability. With Aerospike as a database that can be your source of truth, we need to inform other databases. We need to be able to push that truth to other sources. So let's say you want to have a reporting database. Let's say you want to have a compliance database that supports a wide variety of older SQL commands. You can do that with our upcoming publication framework. You can simply tie all Aerospike writes with certain filters off into other systems, be it a message queue, be it an outside database, and we'll give you a plugin framework. If it's a proprietary system, that's great. Our first early access guys are doing exactly that. They have a proprietary in-house message queue. They're going to be pushing Aerospike writes all the way through to that message queue for some key events. We're excited about that. This one, sorry about that. Oh, what's going on? Okay, devices. There's a great session this afternoon from both Intel and also from ScaleFlux. Let's talk about persistent memory first, in brief. Persistent memory is an extraordinary technology. It's part of the Optane family from Intel, and in my opinion, they are not getting enough credit for it. I commonly say, my little blurb about it is, in the history of computers, we have had 3 ways of storing data. You either take something and you burn a hole in it, and that's your punch card, your paper tape, those of you who have a few gray hairs, or also CDs. CDs are a hole in a reflective surface. So you either burn a hole in something, or you create a little spot of magnet, right, and that's today's rotational disk drive, or you create a circuit that's going to hold a charge, and that's NAND and DRAM. Those are the 3 ways of storing a bit. Okay, Intel took it upon themselves to spend approximately $10 billion to create a 4th way. That 4th way involves taking essentially a small piece of glass and melting it. When you melt glass and cool it, if you cool it slowly, it creates a crystal. If you do it fast, it creates an amorphous solid. Those have 2 different resistive values. That's a whole new way of storing bits. So Intel's persistent memory, Intel and Micron, they co-developed it. It has new characteristics. So please join the talk about that. Aerospike is optimized for it. We have a whole concept about how to use this. Feel free to talk to us or Intel about it. We also work with some of the new up-and-coming flash device makers. You'll see a few of them in the room today. ScaleFlux will be talking about some of the work we've done with them with garbage collection improvements. Aerospike doesn't matter unless you can deploy it easily. And today, agility is formed by working in the cloud. Aerospike is known as a bare metal database for in-memory, but it's not true. Over half of our customers, this slide says 25%, it depends on if you measure by size or by customer count, are in clouds. People use us in the cloud, and they love us in the cloud because of the availability of being able to have a cluster and the agility of being able to snap in new database nodes. Aerospike is a great cloud database. And also efficiency. Clouds are already inefficient because of virtualization. Adding more efficiency, sometimes you need it. So we have done some great work already in being in the marketplaces in all of the public cloud providers. We look forward to even better and tighter integration and offerings that are directly in those clouds. Aerospike is also introducing a managed service because you don't want to have to learn how to run Aerospike. I get that. I wouldn't want to learn it either. But we're the guys who know. We should be the ones who are experts at it, and we are happy to take off of your hands the burden of learning Aerospike and running it on a day-to-day basis. As Srini said, we built that team to do it. It's a 24/7 team already, and therefore come to us if you're interested in it, and we will help you with that, put together a package if you want to get started quickly and don't want to take on that operations cost. Finally on this slide, I'll call out the orchestration systems. So orchestration is critical to the new world of agility. Kubernetes is taking over the world. We're betting on Kubernetes. We also have some great pivotal systems. But we believe that if you want to just start a database, you should be using an orchestration engine. That gets you to running an infrastructure faster and better. As we have gone into the enterprise, we have found that small connectors make a big difference. When we go into, let's just say a bank, but it happens everywhere, they want to know if Aerospike is running. They want to know how to solve a problem in their infrastructure when things get slow, when they add more data, when something unexpected happens. For example, and there's a lot of monitoring systems, so we have to knock those down one by one. Come talk to us. Come talk to my colleague, Bharath. Where's Bharath? There he is. This is the man who is in charge of all the connectors. Come talk to him. Come meet him up and say, I need this one connector. I had to build it, and I want you guys to support it instead. And if you only did that, I could roll out Aerospike faster because we love your database. That's the man. Go meet him up. Let me also call out for a second AI and ML engines. It has come to our attention that most Aerospike users are building extreme scale machine learning systems. We did not know this. And you'll hear just about this in the very next talk from Mikhail. It's a talk I saw at QCon in London. It's an excellent talk, so we've made sure that you don't have a chance to go hear anyone else. And so we need to be able to provide the data, underlying data core for machine learning, not just for people who roll their own on their own frameworks, but also to frameworks that already exist. So the exact nuts and bolts I will leave to Mikhail in his talk about the kind of data shapes you need for machine learning and why high-scale machine learning works on top of Aerospike uniquely as a database. But it's something that we've determined from our customer base. So anyway, we need to do all of the small pieces of work to be able to make enterprises work. Finally, we are here to listen. The way that Srini and I have succeeded was not by just simply building a bunch of technology, but by listening to what you guys want to do with our product. We've built a company, we've built a team, and a business model to support over the very longest haul with some of the most gold-plated investors on the planet, because we're going to be here for you next year, the year after, and therefore, we're here to listen.